Alright, let's do the 9th day of Advent of Code in the God's Temple. Thank you so much, Galcomp, for Twitch Prime subscription. Thank you, and welcome to our epic AoC in HolyC Club. Smoke Basin. I have no idea what the fuck is that supposed to mean, but okay. These caves seem to be lava tubes. Okay, so what is a lava tube? All right. Oh, okay, that's very interesting. I didn't know that there is such a geological structure. All right, so I'll know about that. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settle like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a heat map of the floor of the nearby caves for you, your puzzle input. Smoke flows to the lowest point of the area it is in. For example, consider the following height map. Okay, feels like BFS of some sort. I can already smell BFS, like it's BFS. Okay, so each number corresponds to the height of the particular location, where 9 is the highest and 0 is the lowest location can be. Your first goal is to find the low points, the locations that are lower than any of the adjacent locations. Most locations have 4 adjacent locations. How many times did we have to say locations? Wait a second, I don't know, like locations. So okay, your first goal is to find the low points, the locations that are lower than any other adjacent locations. Most locations have adjacent locations, up, down, left, right. Locations on the edge of the corner of the map have 3 or 2 adjacent locations, respectively. Diagonal locations don't count as adjacent. Every time the problem says location, you have to take a shot. So, anyway. Let me see. I have 4 adjacent locations at the edge corner. I have 2. Okay, so that's actually a classic thing. In the above example, there are 4 low points, all highlighted. 2 are in the first row, 1 and 0, and 1 in the middle. The risk level of a low point is 1 plus its height. In the above example, the risk levels of the low points are 2, 1, 6, and 6. The sum of the risk levels of all of the height map is therefore 15. So this is our proof of solution. I really like to call this a proof of solution, right? So there is some sort of a solution that the author expects from you, but since it's too big to put into this thing, you have to sort of compress that solution into a single number, like the proof of solution. And our proof of solution is basically sum of their heights, like plus 1, right? Something like that. Find all of the low points on the height end. What is the sum of the risk levels of all low points on your heat map? Okay, so not heat map, but height map. I keep pronouncing it like a heat map. Okay. So let me see. So I'm gonna go into AoC 2021 and I'm gonna start AoC 2021 virtual machine, because we're doing that in HolyC, and HolyC works only in TempleOS. So we probably need to do something like a new day, right? So this is going to be new day, and it's a 09th day essentially, right? So, and here our hours 9th day. So I'm going to exit that, and I'm going to just quit the QEMON. Then I'm going to try to mount this entire thing, and let me go into MNT home. AoC, I actually wanted to go to the 9th one. Right, so here it is, and here's everything that I wanted to have. Well, is that 9th one? Yeah, it is 9th one. So this is our sample, right? This is our sample, pretty straightforward. I'm gonna include that sample in there, sample txt. And let me quickly copy paste it into that thing. Boom, I'm gonna save that. ed input txt. Okay, so let's take a look at our input. Ooh, that's that's pretty sexy. Okay, so let's actually grab this entire thing, and I'm gonna do that and save this entire thing. Okay, cool. And let's go back, run AoC 2021. Cool. You can theme TempleOS or it's some sort of fork. Yes, because you can modify the source code. So the answer to both of the questions is yes. You can theme TempleOS, and it is a fork. The reason why you can theme TempleOS is because you can modify its source code, and once you modify a source code, it's basically a fork. Well, in reality, I didn't really modify the source code, right? So you can set the theme by setting the palette, but then I also had to do a little bit of like a hack to reset the standard palette. So is that like a fork or something? I don't know. So it's hard to tell. Anyway, everything is open in this operating system, so everything is a fork, essentially. Okay, so let's actually go in here, and so here is our sample. This is not what I wanted, right? So this is not what I wanted, so this is the... It looks a little bit smaller than I expected. Is that because of the font? It is because of the font, right? So this thing feels a little bit higher, but this one lower, but they still have 5 lines. Okay, so I got debated by the font a little bit. That's fine. That is totally fine. Okay, so we read this entire thing, right? We read this entire thing, and the question is how we're gonna be parsing all of that. That's a very interesting question. So we need to sort of like split everything into lines, right? Maybe we're gonna allocate some sort of array, right? Array of lines. But the question is, what's gonna be the size of that specific array? So maybe some sort of like a lines capacity. So we need to figure out what is gonna be the lines capacity. We probably can take a look at the input, right? And see how many lines we have. We have, as you can see, 100 lines, right? So this is essentially 100 lines. We can set the capacity of the lines to 128, right? So, and then I can keep track of how many lines we already read, lines size, or maybe lines CNT. So, right, before trying to read anything, I'm gonna set the lines CNT to 0. And I'm gonna start doing the reading process. So SV size greater than 1. And in here we're gonna be doing what? I'm gonna do SV chop word. I have to provide the source from which we're chopping everything, and then lines. Right, so this is gonna be lines. Lines CNT. There we go. So we're reading all of that into the lines, and then we also need to chop the new line, right? So we have to do chop left from SV as well. And then we also need to do line CNT++ to increment this entire thing. There we go. So the cool thing about this entire stuff is that the lines count is essentially the height, right? It's basically light. Height, not light. And so maybe because of that, I should rename lines count to like rows, right? And the columns is going to be essentially the size of the first line and whatnot. But maybe not. Maybe it's like waste of time at this point. So whatever. So let me try to read this entire thing, and might as well go ahead and print some sort of information. D lines read. Right, so this is going to be lines CNT. I want to see how many lines we read. We read 54 lines, which is not correct, right? So this is kind of a bullshit. Not gonna lie. Chop word. I think I know what the fuck is going on. Chop word actually chops alphanumeric shit, right? It in fact chops alphanumeric shit, and we want to be able to chop both alphanumeric and numeric shit. So let's actually go into a chop word. Yeah, so basically it checks is alpha. Right, and is alpha only looks into A through A to Z, like small and capital. I think we need to introduce something like is al num, right? So, and we're gonna do the following thing. So we're gonna do it like that. Right, return is alpha, or isDigit, and I'm not really sure if we have isDigit anywhere defined. I didn't see it at least, so we'll have to define it ourselves. We'll go ahead and do that. So boolean isDigit u8 x, right? Return 0 less or equal x less or equal 9. So in HolyC, as you can see, you can do the Python comparison, right? It does work in HolyC. Thank you, Terry. Very cool. I really appreciate that. You didn't implement, you know, even simplest type checking, but at least you added a little bit of a convenient syntax. All right. So what do we have in here? What do we have in here? Is our num chop word, and instead of is alpha in chop word, we're going to be using is al num, right? So I want to check if everything compiles in here. Everything is compiling here, so that's fine. That's pretty cool. Right, so now if I try to do this thing, it says read 5 lines. So basically it read everything correctly. Okay. So now we should be able to just go ahead and solve the problem, but to solve the problem we probably need like 2 counters, right? So let's do something like row and column, right? And we're gonna start iterating everything by rows first. A row is gonna be equal to 0 up to lines CNT, right? Plus row. Right, the next thing is gonna be column, starting from 0, column less, and we basically can take the first line and take a look at size, right? So basically, we're gonna assume that the first line has the same size as the rest of the lines, right? So it might not necessarily be true all the time, but for our particular case, we're gonna assume that specifically. All right, so we have something like this. Now we need to take a look at the neighbors of the cell. We need to take a look at the neighbors of this cell. Maybe we can define something like a function that checks whether a particular thing is low point, right? So let's do something like this. If is low point, right? Is low point row and column, right? We're going to, I suppose, just take the entire thing, right, like so. Lines, row, begin, column, right? And then we're gonna subtract 0 to convert a character into a digit, and we're gonna add 1, right? We're adding 1, and we have to add that to like a global answer counter. So this is gonna be answer plus equals. So, and we also need to maybe define that variable here, answer, right? There we go. And after that, we should be able to just print the entire thing to the standard output. So this is going to be part 1D, and this is going to be the answer. So if I try to compile this entire thing, invalid L value at 30, and I hope it's talking about is low point. Okay, that's actually very cool. Right, so let's define this entire thing. So it's going to be boolean is low point I64 row, I64 column. Right, and for now I'm gonna basically return false, indicating that it's not implemented yet. So what do we have in here? Unused a couple of variables, and the final result here is really huge for whatever reason, and this is probably because I have not initialized the answer variable. So this is something that we have to do probably. Let's actually initialize it somewhere here. Answer 0. There we go. So this thing has to be 0. It really annoys me. It really annoys me that Terry found time to implement unused variable check, but didn't have time to implement even the simplest type checking of different kinds of pointers. This is really annoys me, right? Because a simple check that you have a function that accepts a pointer to one structure, and you're trying to give it a pointer to a different structure. No. He didn't implement that, but he spent some time checking for unused variables, right? what, like, obviously he could implement these checks, but he just decided not to. Okay. That's what bothers me so much. Anyways, I'm sorry. I'm sorry for ranting. We need to implement isLow, right? So we need to implement isLow, and to implement isLow, we have to iterate through all of the neighbors, right? So, and I suppose it has 4 adjacent things, right? So it basically has 4 of them. So we can just like check all of them, right? So we can have an array of directions. So is it 4? I forgot if it's 4 or not. Do not count as adjacent. Okay, so that's cool. So let's define something like directions. I don't know. So dirs. We have the amount of dirs, and then we have like 2 elements in here. I wonder if I can just do things like that. Right. Can I do it like that? So this one is going to be -1, 0. Right. This has to be a comma. Then 0, -1. Right. 0, -1. Then 1, 0. 0, 1. And of course, we want to actually align everything perfectly, so everything is parity. Okay, that's cool. So these are all of the adjacent things. Very cool. So, and in here we want to have a variable that will allow us to iterate through, starting from 0 up until dirs count, dirs CNT. There we go. Plus I, alrighty, cool. And I think so this is the initial row, right? So this is the initial row, and do I want to like define an actual row in here? So row and column, and call this thing row 0 and column 0. That might be a thing that I want to do, right? So then later it is a little bit easier for me to do something like row equal row 0 plus the direction I, right? And here we can define something like a row, right? So that's actually kind of cool. And then column equal column 0 plus direction I, column. There we go. So, and that means we want to define, so I didn't define dirs count, right? So I didn't define. Do we have enumerations? Do we have enumerations of our nations? No, we don't. It's not going to help me in this particular case. So I'm going to define row, which is 0, and then I'm going to define column, which is 1. Right, and I also want to define dirs CNT. Right, I want to define dirs CNT, and this is going to be like 4 of them. Okay, that's cool. So we have row and column, the actual row and column, but we also want to check if it's within the bounds of the entire thing. So we need to check whether, man, I really wanna. Okay, so that's fine. So 0, like row has to be something like this, less than lines CNT. So this is the first condition. Right, and the second one, this column has to be something like lines 0 size. There we go. If both of these conditions are true, right, if both of them are true, we should be able to finally, you know, access this entire thing. So let me think. Lines row and column, starting with the begin, rows and column, right? And we need to confirm that this entire thing is higher than the rows 0 and col 0. To be fair, I want to have 2 separate variables to which I can assign this entire thing, right? So maybe I'm going to call this n. And this one is going to be more of a... So this is the neighbor and this is the point, right? So it's going to be n and p. Right. So though I can sort of specify the value of point at the beginning. So this can be lines, row 0, begin, column 0, right? So, and then I can just do that. And if the neighbor is bigger than point, right, strictly I suppose, rather, if the neighbor is less or equal to the point, we might as well straight up return false, indicating that this is not a low point, right? So this is not a low point, otherwise we want to return true. So I need to double check that the definition of low point means that strictly lower, right? It's are lower than any of its adjacent locations. Okay, that's cool. So that means we implemented this entire thing, and this thing does not compile. Let's take a look at the place where it doesn't compile. So it says something about row, right? So because this thing is called dirs, right? So this is called dirs, and it's 15, right? So, and as far as I know, the proof of solution for the sample is in fact 15. There we go. So cool. Now, I suppose we want to just switch to the input, right? And let's take a look at the proof of solution for our input. So according to my solution, it has to be 504. And if I put 504 into this thing, it will tell me that I didn't fuck up, actually. All right, so here's the solution for the part 1. First try, by the way. First try. Was actually very easy. So it's a part 1. What did we expect? What did we actually expect in here? Alrighty. So let me quickly do a committee and maybe even a pushy. Right, so it's going to be sync, and we're going to sync that into the host, AoC 2021. Alright. So AoC 2021, and I'm going to add home, right. So let me see, commit, add day 09 part 1, right? Day 09 part 1. I'm gonna push that right into the repo. Okay, so and continue to part 2. Next, you need to find the largest basins, so you know what areas are most important to avoid. I don't know. A basin is all locations that eventually flow downwards to a single low point. Okay, therefore every low point has a basin. Okay, you need to find the largest basin, so you know what area are the most important ones. Okay, therefore every low point has a basin, although some basins are very small. Locations of the height 9 do not count as being to any basin. I hope I pronounced that thing correctly. Let me double check. So we're gonna go into the Google Translate. I'm gonna go to basin, right? So let me quickly boom. Basin. Okay, sure. And basin is translated as what? Gradient translation. A wide round open container, especially one used for holding liquid. Okay, so that makes sense. Okay. So therefore every low point has a basin, although some basins are very small. Locations of height do not count as being in any basin, and all other locations always will always be part of exactly one basin. So the size of a basin is the number of locations within the basin, including the low point. Okay, so the top left basin size 3. Okay. So is the basin considered like, okay, so it is not considered. So low point, it is rather interesting. So I do not understand the definition of a basin that eventually flow down into a single low point. All right. 3, 2, 1. Okay, so 3, 2, 1. That makes sense. If you sort of like can climb up from a low point to this thing. It is a paste. Okay, this is actually super easy. All right, the top left basin is size 3. The top right basin is 9. Right, so you start from here and you can flow up in here and then you can flow up in here. The middle basin is size 14. Right, so yeah, this one makes sense. You can up in here. The bottom right basin is size 9. Find the 3 largest basins and multiply their sizes together in the above example. All right, find the 3. How, like, what do you get if you multiply together the sizes of 3 largest basins? All right, so that should be pretty straightforward, not gonna lie. So essentially, what you want to do in here, right, what you actually want to use in here, you want to use BFS. So breadth first search. And essentially, you're gonna send a wave starting from the low point, right? And you're gonna only allow the wave move to the neighbor cells that are greater than 1, right? Exactly greater than 1, so they can sort of like climb up. And then you basically mark the whole like basin, and then you can count its size, right? So you can count its size and stuff like that. The question is, how are we going to determine the size? It's super easy to send the wave for the starting from the low point, but then how do we count everything? So we can basically, yeah, we can basically just count like how many of these things we've got. Though while we're doing BFS, right, every time we introduce a new point into BFS, we can just add 1 to the global counter of some sort, and that's gonna be fine. So yeah, I guess that's fine. Can you also do DFS? I think I can also do DFS, to be fair. Right, so what's important is that whether we marked, yeah, whether we marked this entire thing. And another interesting thing, do basins even, how to say that, overlap a little bit, right? Okay, so to be fair, I want to make a small break super quick because I want to refill my water and stuff like that. And after the break, we're going to code BFS or maybe DFS super quick. So let's go. All right, let's go ahead and code the DFS. All right, I'm gonna restart my virtual machine. Super quick, super quick. And let's go. So again, we'll have to keep track of the already visited like cells and stuff like that. So we might want to allocate enough memory for that too.
Zazil, you are the best.
Thank you, Altair, for 10 months. You are the best of Tier 1 subscription. Thank you, and welcome back to our AoC in HolyC club. Holy freaking C, my god. All right, so let's continue. So we have lines in here, and this is the lines count and stuff like that. And what I want to introduce something like a visited, right? So which indicates whether we visited a particular thing or not. The amount of rows is going to be like lines cap, and the maximum size of that thing is going to be probably equal to whatever we have in the input. So what's the maximum line we have in here? So the columns indicate that it's 100. Okay, so we can literally use the same size. I can just use lines cap in here. So it's going to be 100 by 128 by 128, which is reasonable enough. Okay, so we have visited, but the problem with this visited is that I suppose it's not zero initialized. The cool feature of TempleOS that I keep forgetting is that it executes code outside of the functions immediately. So one of the things I can do, I can just do memset visited zero size of visited, and that way I can sort of zero initialize this entire thing. I can zero initialize it right away. And to be fair, maybe not. It will not allow me to call solution part 2 twice. So I'm gonna probably keep it like this. Anyway, So let's actually focus on the part 2. So here's the part 2, and I suppose one of the things I want to do first is extract the process of reading the input from the file. Right, so because the process of reading is going to be the same for both of the parts. So let's go ahead and do that. U0 read input. Right, so this is going to be something like this, and I forgot to put this thing in here. So the way we're reading input is like this. So here is that. And then we should not forget to free the allocated memory, because the memory is allocated by file read function. So we're going to put it in here. All right, so this is a lines count, and everything seems to be fine. Right, do we need anything else in here? I don't think so. The only, yeah, rows and columns are not needed here, that's for sure. So, okay. So here instead we can remove that thing, and then remove this thing, and also remove this thing as well. I don't know what the fuck has happened here, so let me remove this thing. So I just want you to remove this line. And then what are we doing? We are reading the input. Read input. So reading the input is abstracted away, right? So this is going to be part 1, and part 1 seems to be working, Cool. So in here I'm going to do a read input, and the next thing I'm going to do, I'm going to memset visited. So visited, I'm going to set it to 0, size of visited. Cool. And one of the things we'll need to implement, we need to have a procedure which performs the DFS, right? So it's going to be, let's actually call it, let's literally call it DFS. It's going to accept the row and column from the cell from which it needs to start, I64 column. And I think it also should return the amount of visited cells, right? And the amount of visited cells is going to be the size of the basin, right? So we could try to return it as the return value of the function, but it's not particularly convenient, right? You want to basically be able to treat this entire thing as, you know, as a global variable. And because of that, it might be easier to accept it as a pointer in here, right? So, so let's do something like size, right? So you basically will give a pointer to the size, and it will increment it for you automatically. Okay. So, and that's basically it, right? So we need to perform the DFS. Which is rather cool, Okay, so when do we mark something as visited? I suppose we're gonna do the following thing. If visited row and column, we're gonna return from this entire function right away, right? So we already visited that specific cell, so bye-bye. Cool. If we never visited it before, we're gonna do visited row column equal to true, right? So it's going to be equal to true. And then we probably want to increment the size, right? Because we found something that we never visited before, so it makes sense to increment the size. And I'm not quite sure, so I think this is what you want to do, right, in this particular case, because of the precedence of the operators and stuff like that. If the precedence of the operators in HolyC is the same as in the PureC. Okay, so the next thing we want to do in here is iterate through all of the neighbors. Luckily, we do know how to iterate through all of the neighbors, because we already done that before. Okay, so we have the function that checks the low and stuff like that. So we might as well maybe copy-paste this entire thing, right? Because that's the way we iterate through the neighbors. I wonder if it's going to be particularly useful. So for that thing to be actually useful, I'll probably need to rename row and column into row 0 and column 0. Super quick. So this is going to be something like that. This is column 0, and this one is also going to be a row 0 and column 0. So maybe I'm going to actually do something like this. Okay, so I and P, row and column. Okay, so we take that thing. I don't think we need this stuff, right? I don't think we need this stuff. So N and P. So this stuff is not needed. So here is the row and column, and we don't really need to check anything in here. The only thing we need to do in here is probably, just call DFS into row and column, right? And if that thing was already visited, right, it will stop the recursive process. If it was not visited before, it will continue the recursive process and stuff like that. So furthermore, like checking whether row and column are within the bounds, it could be probably done like somewhere here at the like at the top of the recursion. I think that's actually a reasonable thing to do. Maybe. So let me think about that. Maybe not, because it's kind of weird. We check in visited here, but then we check in out of bounds here. So it's kind of like, doesn't really matter that much. So that's pretty much it. So I think that's the whole thing. And one of the things I want to do, I want to just iterate through all of the low points, right, and call DFS on all of them, and then visualize the visited map. I think that would be actually kind of cool. Yeah, I want to do that. So let me go ahead and see if this entire thing even, compiles. Of course, it doesn't compile. Let's go into 85. So what is it complaining about? Oh, this is because I forgot to pass the size. I'm surprised that TempleOS, I mean HolyC, checks that you call function with the right amount of arguments. I'm actually surprised. So I'm always surprised by any checks HolyC does, right? Because, yeah, anyway. Cool. So the next thing we need to do, we need to have I64 row and column, right? So, and let's actually start iterating. Row is going to be 0, row less the lines CNT plus row, and then for column equals 0, column less than lights CNT plus column. And here we can check if this is a low point. I just realized that I'm making a very huge mistake. I forgot to check if a row is grown relative to the current thing. I forgot about that. That's very important. That is in fact very, very much important. And that will require the variables n and p. So p stands for the position, the current one, and n stands for the neighbor. All right, so I completely forgot about that. So luckily I remembered. So we need to do lines. We take a look at the row 0, right? And then we do column 0, and that thing basically gives us the value. So we might as well... Do we need to convert that to anything in here? I just realized a very interesting thing. I compare their values, but I never convert their values from digits to... from characters to digits, but it still worked out because they're, sorted, in a particular order, right? So the character 0 is less than the character 1 anyway. So this is one of the mistakes I'm making here. Like, I mean, it's not a mistake, but I just didn't intend that. I simply forgot to do that. So because of that, it might be considered a bug, but maybe it's fine. All right, so for the neighbor here, let's do the following thing. We're gonna do n lines row. Begin column, right? And the only the only case when we're gonna look into that is when the neighbor is one height higher than the current point. So in that case, n minus p has to be equal exactly to 1, right? So it has to be equal to 1. So this is the neighbor, and it has to be bigger. Okay, so that's fine. Okay, that's probably the thing I want to do in here. Right, and after that we're just going there. Alrighty, so looks cool. Now, is low point, right? Is low point, we provide the row, we provide the column, and if it is in fact a low point, what we want to do in here, we want to call DFS on that thing. So DFS row and column. Right now we're not going to keep track of the size, so I'm just going to give it the pointer, but I'm not going to like care about it too much, right? So whatever, it can overflow or whatnot. The only thing I want to see is basically visited map, right? So visited map. I just want to visualize like how DFS like went through all of these things and stuff like that. So let me see. It does not compile 104. What do we have in here is because VisitMap doesn't exist. I don't know why I expected. Okay, visited map. Cool. So in here, if I run it, so at least it stops. So it's already calling DFS, by the way, hopefully. Yeah, it is already calling DFS. So that means it's already done something. And now let's try to visualize the map. So there's going to be a rolling column. Right, so this is going to be something like for row equals 0, row less than lines CNT, plus row. We'll probably need like a body in here because we'll need to print the new line and whatnot. Okay, and then we do column equals 0, column less than lines 0 size, plus column. So, and in here, let me think. So we need some sort of a condition, right? We need some sort of a condition. So if visited, row and column, if this entire thing is visited, we're gonna print maybe star, right? We're gonna print star, otherwise we're gonna print a dot, right? So, and after that we need to print the new line. So what are we reading in here, by the way? We are already straight up reading the input. I don't think it's gonna be a good to visualize the whole input because it's rather huge, right? So let's take a look at it, and here is the whole visualization. Is it correct? It doesn't really feel like a correct one, to be fair. It doesn't feel like a correct one, that's for fucking sure. Oh, I know why. Because I'm not iterating this shit correctly. So I can already see that. Yeah, I see that. Your daddy give you good advice. And now everything is basically filled, which again doesn't really feel like a correct one. Interestingly enough, we know that one of the one of the points, so 0, 1, we might just try to call DFS on the 0, 1 point, right, just to see what's going on in there. So let me quickly do that. So this is going to be something like that. I'm going to just comment it out, and it's going to be DFS, and row is 0, and the column is 1, and size doesn't really matter in this particular case. So it was correct. Surprisingly, it was correct. So that makes sense. All right, so what about this one? Row is essentially 0, right, but the column 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, I'm an idiot. I forgot from which point I started to count this entire stuff. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has to be 9. Okay, so if I put 9 in here, it seems to be correct. It in fact seems to be correct. So I'm just like worried a little bit that they're going to overflow. Right, so is that even a correct way of doing that? I'm not sure. Because if you basically allow them all to be there, is it gonna even look like that? I'm not sure. It would be kind of cool to mark different basins with different visited things, if you know what I'm talking about, like just different visited things to confirm what the fuck we're doing. Right. So, and also, do they even overflow? I'm not freaking sure. So this one, oh, I forgot. Okay, that explains why the fuck it is so weird. I forgot very important condition, right? That 9. Okay, locations of height 9 do not count as being in any basin. All right. That is very important. I completely missed that one. I do remember reading it, but I completely forgot about it while implementing this entire thing. That is very, very important. Anyway, so here, what do we do here? I suppose we can do something like this. So if this thing is okay, and difference between them is that, and the neighbor is less than 9, right? Maybe we can even do something like less than 9. And if I try to run this entire thing, yeah, probably I need to go back to my to my original code in here, right? That looks already more believable. That looks already more believable. We can already clearly see, right, clearly see where 9s were. Can I do something like that? So here are the 9s. That is very, very cool. All right. So it would be kind of cool to also print the actual map side by side. The actual map side by side. Just to see where the 9s are, but maybe we can quickly do that. All right, so height map. So I'm gonna put it in here, and this one should be relatively straightforward, right? So we can just basically copy paste this entire thing. So this is gonna be height map. And when something, well, it's not really about visited or not visited, it's more about the character that is there. Right, so maybe I'm gonna actually start it like that. Okay, so this is gonna be this, and lines, row, begin, column. Right, so I'm gonna try to run it, so, and there we go. So we can clearly, well, it's not that clear, not that much clear, but here's 3 9s, and here's these 3 9s, and all of that does make sense a little bit. Cool. So now we also need to do the following thing. We need to find the 3 biggest, basins in here. And the question is where we're gonna, how we're gonna determine that. I have an idea. Maybe we can put all of the sizes of the basins into an array, then just sort that array in reverse and just take 3 biggest. I think that's the easiest thing to do. So we have the size of the whole map is 100 by 100, right? So that means it's going to be 10,000, and we can, this is like the upper limit of all of these things in there. Right. So it's probably going to be smaller, but that's the upper limit anyway. Let me allocate a little bit of memory for that as well. Okay, so let's start doing all of that. Okay, if this thing is a low point, we are resetting the size becomes 0, and we are going to append the size, right? Append basin, right? Append basin, and here we're gonna have this following thing: basins capacity, right? So, and then we're also gonna have another thing, basins count, which is essentially we can initialize that thing in there, right? So, I mean, why did I remove that? I don't have to remove that. Basins CNT, and in here we're gonna do the following thing: basins CNT equals 0. And we need to implement append basin, right? U0 append basin and I64N or whatnot. Basins CNT++ equal N. So you know what, this is such a simple line, I might as well actually inline it. So I don't know why I wanted to like create a separate function for that, so it's fine. Basins CNT++ equal size, right? So I'm gonna remove that stuff, and I should be able to remove this stuff as well. Cool. So, and if I remember correctly, if I remember everything correctly, TempleOS does have a sorting algorithm. So you have sort I64. No, you don't have a sort I64, but we do have just sort. Okay. I need to jump there. And how does it work? So sort lines, no, this is not. Oh, I think I remember. I think it's called qsort. Yeah, it is called qsort, and yeah, there's even qsort I64, which is exactly what I need in here. So it has the base, oh, it's a different one. I'm reading the different one. Okay, cool. So base, the amount of elements we're sorting, and the compare function, right? So does it even check that the compare? Okay, so maybe not. Where does it call compare function? I don't see the fp compare function being used. Okay, so it just straight up uses compare function without checking whether it's null or not. So you have to provide the compare. Right, so let's actually do something like a reverse CMP. Reverse CMP. So I64, reverse CMP, I64A, I64B. Right, so I64B. There we go. And for now, I'm not sure. So I suppose reverse MP works like, yeah, you need to do something like A minus B, right? So this is going to be A minus B. So we do Q sort. We're going to do Bayesian's CNT. That's the amount of the thing. And then we do reverse MP. Though the functions should be called like with this stuff. So with the Pascal case or something. Want to be a little bit consistent on that part. So we sorted this entire thing, and what's the proof of solution? It's the multiplication of these three things, right? So it's the multiplication. Right, so I can do something like maybe part 2 d Bayesian's 0 multiplied by Bayesian's 1 multiplied by Bayesian's 2. Right, so and if I try to run this entire thing, it does not compile. Let's try to figure out why. So Bayesian's, because it doesn't know what's the capacity, Bayesian's capacity, and I'm gonna just like assume that it's gonna be lines capacity multiplied by lines capacity, because 100% is not gonna be bigger than that. Right, so okay, this is another one, I34, 134, so what is it complaining about? Bayesian's count, a reversed CMP. Let me take a look at this function one more time. So this is going to be something. Okay, so I think maybe you have to sort of. Yeah, I think I do remember Terry saying that if you want to have a pointer to the function, you have to specifically say it like this. Okay, 243, is that a correct thing? Is that a correct thing? 200, it is not correct thing. All right, so maybe we are like sorting all of that in a not correct order. I want to actually see the order of this entire thing. So let's actually quickly print them all. For row equals 0, row less than Bayesian's CNT plus row, and in here I'm going to do the following thing. So this is going to be something like this, Bayesian row, and let me take a look at all of them. So it's going to 3, 9, 9, 14. Is it 14? Yes, it is. And okay, so it sorted them in not the order that I expected them to sort, so it's actually quite easy to figure out. Okay, so that was easy, so we can quickly go ahead and just fix that. There we go. So 1, 1, 3, 4. Right, so it's a 1, 1, 3, 4. Cool. And now if I switch to my actual input in here, right? So the answer is 115, 68, 84. Okay, so let's actually take a look. Oh my god. So okay, here we are. So let's try to submit that. 115 6884. Shit. 115 6884. It's not the answer. It is too low. All right. So let's return to day 9. Apparently something is not correct in here. Something is definitely not correct. So let's actually go back. So maybe I was too fast. I wonder if okay, so at the end of the part 2, how many of these things I've got? How many yeah, how many sizes? So I reset the size, and how many Bayesians did I find? Right, I want to just print this value. Right, so let's actually print Bayesians CNT. Okay, so there's like 221 of them. So what I have missed in here, So 1, 2, 3. This one is really interesting. I think I misunderstood the definition of a basin. Okay, so it has to be increasing. Okay, it has to be up. I don't know why I just assumed that it has to be by 1. It has to be increasing. Okay. So let's quickly fix that. So it's a single thing. Neighbor has to be strictly increasing or the same. Could it be the same though? Or could it be the same? That's a good question. That's a good question. Could it be the same? Is there any example when it is the same? Probably. I need to read that very carefully. A location that eventually flows down in a single low. Therefore, every low point has a basin. Location that eventually flows downwards to a single low. Various small locations height can be basin, and all other locations will always be part of exactly one. Says the basin. Okay, they don't really say that. Alright, but it feels like they could be, if they're the same, they could be that, right? Because if it's the same, it's just like flows. Yeah, so we have to assume that the neighbor has to be greater or equal to the point. All right, and if I try to do that, so we didn't really print anything, and I wonder why, because I actually commented that out, right? So I actually commented that out. Probably, does it really change anything if I change this thing like so? I think it doesn't change anything. Wait, does it? 115, 87, 52? Okay. My brain is already incapable of understanding what the fuck is going on, because I cannot keep that number in my head. Right, I just can't keep that number in my head. Alright, so I have to copy paste this entire thing. And because they're all like 155 and... right, so there is literally no difference between them. Right, it doesn't matter. It doesn't matter. So I can do 155, 155, 80, 87, 22. Right, first try. So there was no another try. This is the first try, okay? So this is the first try. We did it. We did it, boys and girls. We actually did it. So that's pretty poug, not gonna lie. So let's do a committee, and maybe even a pushy. How about that? So also let me actually enable the part 1. Yeah, so basically we have this kind of thing. So the author debated me a little bit, just a tiny bit. Right, I thought that it has to be like by 1, but I don't know why I assumed that. So that was actually very silly of me to assume. Okay, so let's go. I'm gonna do sync, and I'm going to basically synchronize this thing into the host, right? So it's gonna be AoC 2021, and let me actually do this entire thing. So sending commit of us. I'm not sure why it did that, but yeah, tmpdd. Oh, this is probably like I probably did something related to tmpdd. I have no idea what, but whatever. So I'm gonna add home, and we're gonna do commit m. And so add day 09 part 2, and I'm gonna push that right into the wish origin master. Okay, guy, that was pretty poug, wasn't it? I think that was pretty poug. So that was day 9 of AoC in HolyC.